So we're going to start with Chapter 6, Section 4 in your books. So I notice half of you don't have your books. That's not good. We're working out of the books this week. You can leave your books at home next week, but this week you need to bring your books. Actually, you won't need them for the rest of the week. But today your assignment is out of the book. It should be a quick lesson, so I'll have to project the book for you. We are looking at still identifying linear and nonlinear functions, tables, and graphs. Okay, so that's our objective for today. So go ahead and write this definition down in your notebooks. I'll give you time to write it. All right, so a nonlinear function, I see non and I see line. I also see ear, but that doesn't matter. Okay, so non-line. A nonlinear function tells me that it doesn't create a straight line. This is a line, correct? It's a line, but it's a squiggly line, right? It's not straight. Is this a line?
Yeah.
Yeah, but it's not linear, is it? No. This is a line, isn't it? Sure it is. It's just not linear. Okay? They're just not linear. All right? So when we take a vertical line test, wait, let me see. Is this a line? Sure, it's just not linear. Okay? It's still a line. It's just not a straight line. It's not linear. Okay? So if I did a vertical line test, that's this thing here. If I drew a line straight from top to the bottom, a vertical line, how many times did I cross this line? How many times? Just once, right? How about this one here? How many times? Once. How about over here? Questionable, right? Questionable. How about this line? How many times did I cross it? Twice. Remember, a function, for every input x, you only get one y, right? So I put in 1/4, I got 1 Snickers. I put in 1/4, I got a Twix. I put in 1/4, I got 1 Snicker. Here, I put in 1/4, I got a Snicker and a Twix. Is this a function? Not a function. That's my vertical line test. Okay, we're going to do some of both of these. We're going to have some equations that come up like this, where they're not vertical, nonlinear, and some where they are. All right? All right, so it says to work with a partner, but you don't have to do that. Just looking at this graph here. Okay, it says graph the data in each table. So we have some data here on your notebooks. I want you guys to create a graph. It's all positive, so you can just do one that looks something like this. Okay, and you're going to graph your data. So you're going to, let's see, it's 300, 285, 250, 255, 240. I would go by maybe 50s, starting at 200, 250, and so on. Actually going up, sorry. And this is going to be 1, 2, 3, 4, 5. Okay, so go ahead and draw a graph on your papers and then graph this data. Go ahead. Don't sit there and look at me. Draw a graph on your paper. In your notes, draw a graph the data. I don't know why you're staring at me. There's no negative, so you don't have to have 4 quadrants. You just need the all positive quadrant 1. How are they doing? Terrible? Some of them are okay. So your bottom, your x values are going to be the top numbers, 0, 1, 2, 3, 4. Your y values are going to be the 300, 285. If you start at 200, go by 50s, you should be able to create a decent graph. You done? What are you waiting for? Stop pounding. I know it's a little difficult to see my numbers. Let's see if I move this over a tad. All right, so I have numbered 200, 250, 300, 350, 400. I've numbered 1 through 4 on the bottom. So this is going to be my x values, and these are going to be my y values. Okay, so my first x, when x is 0, y is 300. So there's my first point. Sit down, Dominic. Don't stand up again. When x is 1, y is 285. So that's probably right under 300. What? It's right here.
Yeah, but no.
Does there need to be a 400? I can label this with whatever I want. It doesn't mean that I'm going to put a point there. 2 is 270. Here's my 2. 270 is going to be around there. 3 is 255. What do you notice about this graph?
It's in a straight line. It's going down.
It's descending, correct?
Yeah.
And then 4 is going to be 240 around here. So if I was to create a line or draw a line, I have what we call a linear line, right? It doesn't curve, it doesn't bend, it's a straight line. You understand?
Yeah.
So is this graph linear or nonlinear?
Linear.
It's linear. Okay, so let's go ahead and graph the second one now. Same idea, okay? These are my x values, these are my y values. You have a broader span, so you might want to start at 50 and go up to 300 on your y values. All right, so I'm going to go ahead and draw my own graph over here. So I've got a couple lines. I'm going to say this is 1, 2, 3, 4. So this will be 0. I'm going to go by 50s. 100, 200, 150, sorry. Going by 50s. And then we have 250 up to 300. So 0, 300, My first point is there. 1, 284, that's got to be above 250, below 300. 2, 236, that's down here somewhere. 3, 156, probably up here somewhere. And then 4, 44. If I was to connect these guys, give myself an arrow. Looks like a pretty rapidly descending. Of course, my points aren't very accurate. Descending point, but it's linear. Would you say it's linear or non-linear?
Linear.
I'd say it's linear. Not very accurate with my little description. Yours might be just as accurate or a little bit more accurate. But you can tell when you graph some data whether it's linear or not linear, correct? So we're going to go on to this next example. Oh, look at, there's the, never mind. All right, so let's go ahead and look at these examples here. Okay, so we're asking to see if it's linear or nonlinear. I can still tell you if it's linear or nonlinear without graphing it. The way we do that is by looking at the change in x and our change in y. Okay, here we have x and here we have y. So what is the change? From 3 to 6, what do we do? From 6 to 9, what do we do? From 9 to 12, what do we do? How about our y's? From 40 to 32, what do we do? From 32 to 24, what do we do? Subtract 8. From 24 to 16, what do we do? We subtracted 8. Okay? So we added 3 consistently, right? And then we subtracted 8 consistently. So this rate of change doesn't change, right? It's consistent throughout the entire table, right? Okay, so because this is a constant rate of change, it's the same throughout on the top, and it's the same throughout on the bottom. This would be a function. This function is linear, okay? We don't have any repeaters, right? So it is a function, and it's a straight line because when we know that, because the rate of change is constant, okay? So a linear function has a constant rate of change. So you're going to write that down because this is going to be important. A linear function has a constant rate of change. Did you write it down? So let's look at example B. Example B, on the top, what is my change from 1 to 3? I added 2. From 3 to 5? Everybody. What about 2? I added 2. From 5 to 7? I added 2. Let's look at the y's now. From 2 to 11, what did I do? From 11 to 33? Is that the same as 9? Let's see, from 33 to 88, what did I do? Are they the same down here? So they're not constant, correct? Since my rate of change is not constant, this is not a linear function. Understand? Does that make sense to you? Constant rate of change, not constant rate of change. Constant, not constant. Linear, non-linear. Yes? So here we have a couple examples, A and B. Here's my line for B. Here's my line for A. Look at them carefully. Talk amongst your partners and your table groups. Are they linear or nonlinear? Okay, so A. Thumbs up if it's linear. Thumbs up if thumbs down if it's not. Up if it's linear, down if it's not for A. A, thumbs up if it's linear, thumbs down if it's not. I don't know what this is. Okay. Kevin. I can't see your thumb. It's back here. What's your thumb, Manny? You say it's linear? Okay, so Manuel says it's linear and the rest of you say it's not. Manuel, why do you say it's linear? A, we're talking about A. Because it's a line. Does it go straight? So is it linear? Could still be a function. If I did the function test, it might still be a function. But is it linear? Not linear. How about B? Thumbs up for linear, thumbs down for nonlinear. Linear or nonlinear? Linear, nonlinear. What is it? I need everybody's thumbs up, including yours, Karina. Thumbs up. Correct. Good job. It is linear. It's a straight line. B is linear. Okay, so we have some examples, 1, 2, and 3. I want you guys to write down in your notes, copy them down, and then decide. Okay, so example 1. Did you have to graph these to find an answer?
Yes.
So I heard yes and I heard no. You need Dominic? Did we have to graph these to find an answer? Who said yes? You say yes, Noah? Do I have to graph these to find an answer? Do I have to graph them to find an answer, Kevin? I don't. I can just find my rate of change. What's my rate of change from 0 to 7? What about 7? I added 7. What about from 7 to 14? What about from 14 to 21? So far it's constant, but they both have to be constant. So from 25 to 20? What about 5? I subtracted 5. From 20 to 15? I subtracted 5. From 15 to 10? Subtracted 5. So constant rate of change, right? Therefore, these are, what are they? Linear. Okay, how about 2 to 4? What did I do? Plus 2. From 4 to 6? Plus 2. From 6 to 8? Plus 2. What about my y's? From 8 to 4? I subtracted 4. From 4 to 0? Subtracted 4. From 0 to negative 4? Subtracted 4. Constant rate of change? Constant rate of change. Linear, nonlinear?
Linear.
What did you say, Christian?
No, you didn't.
You said not. You did not.
Okay. Number 3 is already graphed. So, do I have to do anything other than look at it?
No.
No, right? So, is this linear or nonlinear?
Non-linear.
Nonlinear. Okay, it's very similar to your homework tonight. Last thing, vertical line test. Okay, so if I drew a vertical line, which I kind of already touched it on, if I draw a line going straight down anywhere, it has to be horizontal, anywhere, I'm only going to touch this function at one point. Okay, this one here, my vertical line touched it at 2 points, therefore it's not a function. Okay, so a vertical line test is going to tell me if it's a function or not a function. It has nothing to do with the linear or nonlinear. It's a line, but it's not linear. Okay, how about over here? Function or not a function? How many times did I touch this diagram? Twice. Okay, so I put in a quarter and I got a Snickers and a Twix. Put in a quarter and I got a Snickers and a twist. No, Snickers and Twist don't cost a quarter anymore. But back in the day, when I was a youngin', walking 5 miles to school, uphill both ways in 10 feet of snow in East LA. No, not really. All right. Okay, so that's all I'm going to do for now. today. Go ahead and take out your books and start your homework.